Welcome to lesson 2 of getting started with scientific computing using the C programming language PSIRDEMATICA. In this lesson, we will be looking at how to create loops in C. So in our lives as mathematicians, we tend to encounter stuff that would have to perform iteratively. So for instance, in numerical analysis, where we can solve certain equations analytically, we would have to use these iterative methods or numerical methods to deduce or get to an approximate solution, right? So in this lesson, we would be looking at how to create loops or create such loops or such iterative process in C. So these loops will help us to perform certain iterative process, probably like the bisection method, which we can use to solve or find the roots of nonlinear equations, and then other iterative methods or other things in optimization, maybe search methods and other things. So without wasting much time, let's get started. So as usual, we open our terminal, we create our file using our favorite text editor, so vim and then lesson 2.c, and then now this opens for us. So first things first, we have to include our standard input output header or library, so that's .h, right? And then our int main function. This I'm returning nothing, so void, right? And then now, so this is loops, so we are creating loops, right? So now there are several loops. We have the while loop, the do while, and then the for loops in C. But then we'll be focusing on the while loops and then the while loop and the for loop. In order to write a while loop, all you have to do is write the statement while, right? Create a parenthesis which will contain your condition, right? So check any condition that returns a boolean. So when we talk about boolean, any condition that returns a true or false statement, right? But then while that condition, certain condition, right? While certain condition is true in this parenthesis, it executes the program or the tags here, right? Or some statements here. So while a certain condition is true, it executes some statements here. So let's look at an example. We want to probably create or print, let's say, the numbers from 1 to 10, right, on our screen. So first we have to declare that. So int, maybe we call it I, right? Now I, and then we first assign I to be probably 0, right? And then now inside our loop, we declare or we decide to give it a condition, right? So while I, right, is less than 0, okay, what should the loop do, or what should our function do? It should first add 1 to I, right? And then after which it should what? Should first add 1 to I, and then also print now. Note that we said I is an integer, so we do %d, right? So we don't forget. Print what? I. So, but then looking at this condition first, before we even run our code, let's see whether this would actually work, right? So print I. let's see whether this works. The condition is saying that while I is less than 0, but then we initialized I to be 0. So would this actually work? Let's see. I is already 0. If we say I should be less than 0, there becomes a problem because 0 is never less than 0. So it means this will never run. Is that not it? So it means that the condition so let's check whether this will run first, right? We call this lesson 2. So GCC lesson 2.c, and then I want the output to be in lesson 2.x, right? There's no error. Let's run it and see. Lesson 2.c or .x. We see there's no output. Why? Because this condition is already false, and since it is false, the print statement will not run. So we would have to change here and make sure that we get a value that is actually huge. So if you want to print from 1 to 10, then you do from 1 to 11. Then once it's I is equal to 10, it stops. While I is equal to 11, the loop stops, right? So let's see whether this will actually run. So we recompile and then try running it. So we see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 has been printed to screen here for us. So if we want this to be printed to probably we want this, the number should be spaced, you can do that. And then if you want to make or print a new line after, you could also do that here. So print F, and then I want a new line here. So basically we save and then recompile our code. There's no error. We run it and then we see the 1, 2, 3, 4 up to 11. So it means that it even runs this before, right? So it checks while I is equal to 10, it adds 1 to it. So which means that it will print it up to 11. If you want it up to 10, then you have to decrease the counter to 10. Then it will do that for us. So basically, or better still, you can put the counter to the 1 I++ beneath the printf, and then this will perform normally. But that's for the while loop. We could also create this same thing using the for loop. Now the interesting thing about while loops is that while loops check whether a certain condition is true and then runs the statements in the loop until that condition becomes false, right? So that's how while loops work, or that's how it works. But then the interesting thing, or the most important thing here, is that what if we want to perform certain tasks a particular number of times? So we want to, let's say, find or search for the minimum of a particular function, but then we want to just perform that search probably 10 times or 100 times and then stop. What then happens? So the while loop, yes, we can still adjust the while loop to do that for us, but then we can use a better one, or sorry, not a better one, but then another loop called a for loop, right, to do that iteration for us. So the for loop is used, right, when you have you want to run something a certain number of times. So for instance, I want to for loop, this is how the syntax looks like, sorry. So this receives certain arguments, right? So first it takes in the initializer, right? Now this initializer is what actually starts, so initializes, so it starts the loop. So this is where the it starts from, right? So initializer, and then after which, separating by a semicolon, it takes in a condition, right? So a condition must be checked, so a certain condition must be true, and then the counter, right? And then you give it a certain counter. So this is how it counts or keeps track of the iteration it's performing, and then runs a certain statement a certain number of times, right? Statements a certain number of times until the condition here becomes what? False. And then the code stops, or it breaks out of the loop. So basically that's something to, if we want to print the same 1 2 3 4, right, here we could decide to use a certain counter. So let's say the same I, since we've initialized it at the top, but then this I we've initialized, right, we could say that, okay, so I is equal to 0, right, which has already been initialized at the top, but let's still say equals 0 here. So for I equals 0, right, now a certain condition, what condition are we using? We want I to be less than what? To be, okay, let's use J here, right, J, so that we get some difference here. So let's say J is less than 11, right? And then here, let's say I equals 1, it should start from 1, alright, but then this is J. Now our counter, so this is just going to be J++, which means that I should just add 1 to the J. So after performing it, so it will first initialize J to be 1, run this statement here. After this statement is done, it adds 1 to the J, and then checks if J is less than 11. If true, it runs this statement again. Now what statement do we want it to run? Let's see, let's still use a printf. Alright, so printf, but then what are we printing? We just want to print the J, so J, or let's print the square, so J times J, right? Let's see something, let's do something interesting. J times J here, right? Sorry, this is percentage D, and then we do the J times J here, J times J here, exactly. So we are using the percentage D because we are returning an integer, but the interesting thing is that we didn't declare the integer. So one way of doing it is we could decide to declare the integer and initialize it here, and this will still work. So let's see what happens. Let's save our code and then try compiling it and see. First, let's clear the screen first, right? And then compile our code. Oh, there's an error. So for expected identifier before the for, so let's see why the problem is. Yes, so actually we are running this code outside our curly braces, right? The curly braces that ends our code. So let's make sure that we end the curly braces down there, and then close or delete these curly braces here. Yeah, so I think this should run perfectly now. We want to print a new line after this code has been run. So new line, and then before this code runs, we want to show that it's what is for loop. So we say executing, so code for loop, right? Interesting. New line. Okay, first let's end this line. We don't want any errors here. Let's terminate this one too as well. we save and recompile. These errors are very important because these error messages help us to decode, to know the problem going on. So once you get these error messages, don't be perturbed. Just take your time, read what it's trying to tell you, and then you get used to it soon. So let's see whether it will still run. Whoa, there's another one, print. So you see that I use print instead of printf. So we'd have to come here, it's here, and then quickly add the f to it. Let's see whether I've not added it anywhere. Okay, there's none. So let's clear this screen and then recompile. Interesting, now we don't have any errors. Let's see whether we can run this code. When we run it, we see that the code for the for loop is what? 1, 4, 9, 16, 25. Let's give it some space so we can actually see what is being printed for us. So we use the \t for a space, for especially for the tab. If you want, the space should be 4 spaces generically. You can use the \t for that. Now this is 1, 4, 9, 16, 25, 36, 49. So this is just practically the square of the numbers 1, 2, 3, 4 to 10. Interesting. So we realize that we can determine when this loop should stop, right? By just giving it a certain condition or telling it to run a specific number of times. So mostly there's use cases for the for loop is when you want to perform something, a task, a certain number of times or a certain number of iterations, and then we use a while loop if you want the task to only finish probably once a tolerance has been met or once a decision is made, right? So mostly we use while loops to toggle decisions to check whether a decision is correct, and then for loops to perform some iterations some number of times, right? Now it will interest you to know that you could also perform or run for loops and for loops. So let's say, and that's called nested loops, right? So nested loops, for nested loops we have, for nested loops, so we could actually have a for loop in a for loop, and this comes in handy if we are trying to, let's say, print out the elements of a matrix where we have row and column wise. So we have a row component and then the column part of the matrix. So we can use the nested loops to iterate through a matrix or an array. So let's see. So basically it works that the same way, right? So let's say this time around int, let's say j, right, equals I equals 1, sorry, and then our condition should be for it to, okay, let's see, just 5 elements or 4 elements, right? So j should be less than 5. Interesting. And then we want the increment, so j should increase, right? And then we put our command or statement inside the curly braces for this. So now we want another for loop, right? So we give it another for loop, but then this time we give it a different what element, so maybe k, so we can use k here. So k also starting from 1, right? We want k should also be less than 5, so that's, we just want a 4x4 element or something, and then k plus plus, and then we put our command in the curly braces. Interesting. Just like this. Now this would also work, right? So now let's see, we want to print what? We are printing Now I want to print A, right? I want it to look in the like the matrix. So let's see. So print A. Now how this works is this. It first makes maybe J to be equal to 1, right? And then from J equals 1, it comes to the K portion, this loop. And then while J is equal to 1, it runs this K from 1 to 4, because we said less than 5. So from 1 to 4, it runs this loop from 1 to 4. When it's done, then it goes back, changes J to 2, comes back here, runs this loop from 1 to 4, goes back, adds 1 to the J to 3, comes back to this loop, and then still runs it from 1 to 4, something like that. So let's see what happens here. So so we want it to print J and then I, right? So let's see something. %d, since they are integers, so %d, and then the elements we want to print are J, I, right? We want J printed here and then K, so J and K printed here for us. And then after each row, right? So after, and then we want to print a new line here, hopefully. Print F. Why do I keep typing print? Probably because, so we have print F of that. So let's see. From here, let's save this and see let's compile, no error, that's great. Then let's run and see. Interesting. So here we could see that we have A11, A12, A13, A14. So this has been printed nicely like a matrix for us. So I'm coming, let's give it some space so we could see what it's actually printing here. So let me just give it some 2 spaces. Okay, I think this is okay. No, this is fine. And then here, let's give it another space here. So /n, and then save and see what happens. So once we save, we run this and then see that yes. So now we have the A11, A12, A13, A14. So it means that this is saying that this is row 1, row 2. So we see that here we have 2, 2, 2, 2. All the K goes from 1 to 4. And then here to row 3, we have 3, 3, 3 here. Whilst the K moves from 1 to 4. So interestingly, we use the nested loops to, you can see, print elements in the form of a matrix, right? So we would be using this to fetch some elements from our matrices and then use it to perform some basic arithmetic. So basically that's for loops. You could have for loops in for loops in for loops. So you could also have nested for loop, which is nested in another for loop, which is nested in another for loop. And that would help greatly when performing some computations with matrices. We'll be seeing those in subsequent videos. I don't want to make this video too long, so basically that's that for while loops and then for loops. We've learned how or why it's needed for us to know about while loops and then what we would be using them for, why we have to know for loops as well, and then their importance. We also learned how to create nested for loops. So in the next video, we'll actually perform a task, right? We would use this knowledge we've learned from loops to create a multiplication timetable, a simple one for that matter. So join us in the next video to see that task. Thank you.